Let's rewind that. Let's rewind that. No. Yeah, I forgot. So estimating mu when sigma is known, right? Because of time and money constraints, difficulty in finding population members and so forth, we usually do not have access to all measurements of an entire population. Instead, we rely on information from a sample. In this section, we develop techniques for estimating the population mean mu using the sample data. We assume the population standard deviation sigma is known, right? Let's begin by listing some basic assumptions used in the development of our formulas for estimating mu when sigma is known. So here goes the sauce right here. Assumptions about the random variable x. I'm good, thanks. We have a simple random sample of size n drawn from a population of x values. The value of sigma, the population standard deviation of x, is known. If the x distribution is normal, then our methods work for any sample size n. If the x has an unknown distribution, then we require a sample size of n greater than or equal to 30. However, if the x distribution is distinctly skewed, right? Definitely not mound shape, a sample size of 50 or even 100 or higher may be necessary. All right. So keep those in mind. Not gonna lie, this is my favorite topic right here. Just nice and simple, you know? Smooth. Right? So an estimate, right, of a population parameter given by a single number is called a point estimate for that parameter. It will come as no great surprise that we use X bar, the sample mean, as a point estimate for mu, our population mean. A point estimate of a population parameter is an estimate of the parameter using a single number. X bar, right, which our sample mean, is the point estimate for mu, period. Even with a large random sample of values of sample means usually is not exactly equal to the population mean mu. The margin of error is the magnitude of the difference between the sample point estimate and the true population parameter value. Right? We're going to hear that word margin of error again coming up as well, right? So when using the sample mean X bar as a point estimate for mu, thank you, the margin of error is the magnitude of the sample mean minus the population mean, or the absolute value, right, of the sample mean minus the population mean. All right, so we cannot say how exactly how close the sample mean is to the population mean mu when mu is unknown. Therefore, the exact margin error is unknown when the population parameter is unknown. Of course, mu is usually not known, and there would be no need to estimate it in this section. We will use the language of probability to give us an idea of a size of the margin of error when we use the sample mean as a point estimate for mu. First, we need to learn about confidence levels. The reliability of an estimate will be measured by confidence level. All right. So let's talk about that. There's a nice little chart in your formula sheet that we're going to go to. So we're going to talk about that. All right. So suppose we want a confidence level of C, right? Theoretically, we can choose C to be any value between 0 and 1. But usually C is equal to a number such as 0.90, 0.95, 0.99, etc., right? In each case, the value of Z critical is the number such that the area under the curve, right? Let me show y'all. You know, this wouldn't make much sense without a graph, so let me get y'all a graph. Whoops, I went a little too far. There you go. So right here, this would be my Z critical, and this is the area critical region under the graph, right? This is our confidence level, is our C. So confidence level is your area under the graph, all right? And then you just find your Z critical from there. But we're a little bit blessed. We are a little bit blessed because we have a table that gives this to us, which you can use for your homework, by the way. Let me advertise that. You can use it for your homework. So the standard normal curve, right, falling between negative Z critical and positive Z critical is equal to the confidence level. The value of Z critical is called the critical value for a confidence level of C. For a confidence level C, the critical value Z critical is the number such that the area under the standard normal curve it falls between negative Z critical and positive Z critical. That equals C. The area under the normal curve from negative Z critical to positive Z critical is the probability that the standardized normal variable Z lies in the interval between negative Z critical and positive Z critical. It's the same thing from the previous chapter. Boom, right? Let's look at an example. Doo, doo, doo. All right, so for example, right? We want to find a critical value. We're going to use table 3 of the appendix to find the number for Z critical of 0.99 or 99% of the area under the standard normal curve that lies between negative Z critical 0.99 and positive Z critical 0.99, right? We will find our Z critical such that the probability, right, between negative Z critical and positive Z critical is 0.99. All right, let me just draw this out real quick, just so that we're clear, right? Imagine I have a bell-shaped curve as such, right? What I'm telling you is that there's a negative Z critical value here, and there's a positive Z critical value here, such that in the middle, this is 99%, right? And all we have to do is just look it up. Simple, right? Let me ask y'all a really hard question, right? If in the middle is 99%, how much is this? 2.58. Oh. Oh. I'm just looking at 0.5. 0.5%, right? Mm-hmm. So that means this is also 0.5%, right? That's what you're saying? Yeah. So what you could do, if you wanted to look this up in the table, right? Just look up from here, right? This top portion. So 99% plus 0.5% gives me what? 99.5%, right? AKA 0.9950, right? You could look this up in your table. All right, let's do that. 0.9950. Let's see. It's 2.58, no? It probably is. Let me verify that. That's the closer number than 99.50. You're probably right. Let me catch up with you. I don't know. Yeah. Yeah, let's see. So you go to your normal distribution table, right? I'm looking for 0.9950, right? 0.99. All right, I'm in the 99 section. On table 3. You don't have to look at it in table 3. I'm getting to that. Hold on. Okay. So I got 0.9949. Oh shoot. me try that again. I got 0.9949 and 0.9951. Remember, I'm looking for 0.9950, which is in the dead middle. So I take both of these z values. So I have 2.57, 2.58, right? And what am I going to do with those? I'm going to take both of those z values, add them together, and divide by 2. All right. So 5758. So I have 2.57 plus 2.58. Then I'm going to divide it by 2. That's going to give me 2.575, right? AKA 2.58. Go ahead. Table 3. Yeah. So I looked in the middle, like right here where all these numbers are, and I was looking for 0.9950. Right?
Right.
Hmm?
89.
89?
89. Page 89.
A9, I guess. Let me see. A9. Yeah. Hmm? Where it says normal distribution at the top. You see 0.9950. You do, it's here. You see where it says table 3? Areas of standard normal distribution at the top. You don't see that?
Take another
It should be there.
That's what I'm saying.
You see this picture right here? You don't see a picture like this? That's a normal curve. A bell shape curve. I think you do. Because the one that I'm trying to use is this one, and that's the one that's on your page, no? Hmm?
Maybe I can't see well.
Yes.
Oh, it doesn't say normal distribution.
It doesn't say that here.
This is the beginning of it. And it says normal distribution.
Oh,
There's a negative side and a positive side. I got you. Good. You're welcome. So inside of the table itself, right? I'm looking for 0.9950 inside here. And I found it right here. I found 0.9949 and 0.9951. The problem is, though, I'm looking for 0.9950. That's in the middle of that, right? And it's one unit. I have one unit to the left, one unit to the right. So 0.9949, 0.9951, I'm going to take those two Z values. One Z value is 2.57, and the other Z value is 2.58.
Well, in the homework, different, I just use table 3.
I know. Yeah, I'm getting to that. Yeah. Mhm.
say that please again.
So I'm looking for 0.9950, right? It falls in between these two values here. Right. So I'm going to take these two Z values, 2.57 and 2.58, right? And then what you're going to do when you take those two numbers, you're going to add them up and divide by 2. And that's what I did over here. It's the first number, where the 0.9949 is, that's 2.57. All right. You see that? So when I add them together, this is what I come out with. Add them and divide by 2, excuse me. Then this is what I come out with, 2.575, which you can round off to 2.58. And just to be clear, that's what Z critical is. Mm-hmm. So I'm looking for Z099, right? So the critical value when the area under the curve is 99%, right? So from the table, I found that to be 2.58. Well, that's it. So this is how to find Z critical for any critical number that they give you. Anything. It could be 81, could be 67, right? This is how you find the critical value for that. All right. Do, 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 do.
Hello.
Hey, how you doing? And then also vice versa, you could have used the negative side to find the negative version of it, but we're good. Also, there's a way to do this on the calculator, if you guys remember from last section. We could look at. The results of example one will be used a great deal in our later work. For convenience, table A2 gives us some levels of confidence and corresponding critical values, Z critical. The same information is provided in table 3B of the appendix. An estimate is not very reliable unless we have some kind of measure of how good it is. The language of probability can give us an idea of the size of the margin of error caused by using the sample mean, X bar, as an estimate of the population mean. Remember that the sample mean is a random variable. Each time we draw a sample of size n, whatever, from a population, we get a different value for our sample mean. And then according to the central limit theorem, all right, let me get the rest of that. Coming back. That's why we have phone cases, so it doesn't affect us, all right? So according to the central limit theorem, if the sample size is large, then the sample mean has a distribution that is approximately normal, with the mean of mu for x bar is equal to mu, and a population mean we are trying to estimate. The standard deviation is sigma for x bar is equal to sigma divided by the square root of n. If x has a normal distribution, these results are true for any sample size. This information together, right, with our work of confidence levels leads us as shown to an optimal derivation that follows to the probability statement. The probability of negative z critical times sigma over the square root of n is less than x bar minus mu, which is less than z critical times sigma over the square root of n, which is equal to our confidence level, right? So the table that Danny used, here it is, right? Here are some levels of confidence and their corresponding critical values already worked out for you, so you don't have to go through what I just did, right? We're drawing the distribution and looking up in the table and finding the z critical values. Here it is, right? If the confidence level is 70%, the critical value is 1.04. If the confidence level is 80%, the critical value is 1.28. The confidence level is 85%, the critical value is 1.44. Simple, right? Any questions
Add and
on this?
minus, that's it, that's all you have to do.
Hmm?
Add and minus, that's all you have to do there.
We didn't get there yet.
Oh.
Yeah. Yeah. But this is just how to find it. This is just how to find the critical value. I cut the I did cut the table off though, so let me give you the rest of the table. You all have this table in your formula sheet. All right? It is. Yeah. This is the rest of the table that I cut off. I'm sorry. So if it's like 90%, it's 1.645. If it's 95, it's 1.96, etc. You get the idea, right? So equation one uses the language of probability to give us an idea of the size of the marginal error for the corresponding confidence level. In words, equation one states that the probability is the confidence level that our point estimate, the sample mean, is within a distance of plus or minus z critical times the standard deviation divided by the square root of n of the population mean mu. This relationship is going to be shown in the next figure, right? In the following optimal discussions, we derive equation one. And if you prefer, you may jump ahead, blah, 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 to discussion about margin error. So essentially, what am I trying to do here? Right? I have a sample mean, but I'm not interested in the sample mean. I want the population mean for whatever reason. Right? Now, I can take many samples and get different sample means, but I want to estimate what could the population mean be. That's what we're doing in this section right now. We're estimating what a population mean could be, or we're building up to it. All right. Just bear with me. Here we go. So this figure, right, shows a distribution of the sample means X bar, right? So the probability that the confidence level, or excuse me, the probability is the confidence level that the sample mean is within plus or minus z critical times the standard deviation divided by the square root of n of the true population mean mu. So what's happening here, right? I'm taking samples and I don't know what the actual population mean is, but I'm I'm confident to a certain percent that the mean is captured in between these two values. All right? That's the lesson here. All right, so optional derivation of equation one for a confidence levels, we know that the probability from negative z critical less than z critical is equal to the confidence level. This statement gives us information about the size of z, but we want information about the size of x bar sample mean minus our population mean. Is there a relationship between z and x bar minus mu? The answer is yes. Since by the central limit theorem, x bar has a distribution that is approximately normal with mean mu and standard deviation sigma over the square root of n, we can convert the sample mean x bar to a standard deviation, to a standard z score, excuse me, using our old formula. Z is equal to x bar minus mu over sigma over the square root of n. Right? So you see, it all connects. It all connects. Now check this out. Next, we're going to plug in that formula into our previous formula that we have from before, right? So substituting, right, in for z, we're going to have negative z critical is less than x bar minus mu over sigma over the square root of n less than z critical, right? Multiplying all parts of the inequality in 4 by sigma over the square root of n, because you want to get rid of the denominator. You have negative z critical, right? Times the standard deviation over the square root of n less than x bar minus mu less than z critical times the standard deviation over the square root of n. That's going to be equal to our confidence level. So equation one is precisely the equation we set out to derive. Cool, 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 cool. All right, let's talk about margin error. This is where it gets good. And you'll probably see this on your homework when they ask you about margin error. All right, so the margin of error or absolute error using the sample mean as a point estimate for mu is the absolute value of the sample mean minus mu. In most practical problems, mu is unknown, so the margin error is also unknown. However, equation one allows us to compute an error tolerance E, right, that serves as a bound on the margin error. So using the confidence level, right, or confidence percent, whatever, we can say that the point estimate x bar differs from the population mean mu by a maximal margin of error. Here's your margin error formula. E is equal to Z critical times sigma over the square root of n, right? This is on your formula sheet in chapter 8. You can take a look at it. All right. Note that formula 5 for E is based on the fact that the sampling distribution for X bar is exactly normal with the mean of mu and a standard deviation of sigma over the square root of n. This occurs whenever the X distribution is normal with the mean mu and standard deviation sigma. If the X distribution is not normal, then according to the central limit theorem, large samples of n greater than or equal to 30 produce an X distribution that is approximately normal with mean, mu, and standard deviation sigma over square root of n. So using the equations 1 and 5, we conclude that the probability is of the negative E less than x bar minus mu less than E is equal to our confidence level. All right. Equation 6 states that the probability is the confidence level that the difference between the sample mean and the population mean is no more than the maximal error tolerance E. If we use a little algebra on the inequality, we have negative E is less than X bar, which is minus mu, which is less than the margin error E, right? And that's building us up to dun, dun, dun. I can't wait for y'all to see this. That is building us up to our formula. So for mu, we can rewrite it in the following mathematical equivalent way. X bar minus E, which is less than mu, which is less than X bar plus E. Since formulas 7 and 8 are mathematically equivalent, their probabilities are the same. Therefore, for 6, 7, and 8, we obtain the probability of X bar minus E less than mu less than X bar plus E is equal to our confidence level. Equation 9 states that there is a chance the confidence level that the interval from negative E to E and to X bar plus E contains the population mean mu. We call this interval the confidence interval for mu. All right. Go ahead. I got you. Wait till you see the example. Mhm. I got you. I'm getting to that. I got you. I got you. I got you. I'm just giving you the theory right now, but I got you. We're gonna simplify this. All right. This was just how to derive it. So check this out, right? Basic definition. So a confidence interval for mu is an interval computed from the sample data in such a way that the confidence level is the probability of generating an interval containing the actual value of mu. In other words, the confidence level is the proportion of confidence intervals based on random samples of size n that actually contain the mean mu. So we may get a different confidence interval for each different sample that is taken. Some intervals will contain the population mean mu, others will not. However, in the long run, the proportion of confidence intervals that contains mu is the confidence level. All right. I'm building it up. I'm building it up. Just stick with me. Not that was no steps in that. There was no steps. But since you want steps, I got you right now. Yes, it's gonna be on the final.
This.
Yeah. This is actually the easiest question on the final. Yeah. Yeah. So, yeah. I got you. I got you. But look, check this out. These are the steps. These are the steps that you was asking for, right? Mm-hmm.
You're gonna give like 5 days. Wow, 5 days.
Mm-hmm. I'm gonna do something even better than that. Let me see.
You put it, I will give you the link there.
You already have that.
Open the book, what you doing?
The formula sheet. That's the answers to all the exam. That wouldn't help.
I got it. What
What you mean that don't help?
I already packed it.
The answers to everything is on the orange packet. Oh. All right, real quick. Here's your steps. Here's your steps, right? So how to find a confidence interval for mu when sigma is known, right? Requirements. Let X be a random variable appropriate to your application. Obtain a random sample of size n of X values from which you compute the sample mean X bar. The value of sigma is already known, perhaps from a previous study. If you can assume that X has a normal distribution, then any sample size n will work. If you cannot assume this, then the sample size has to be n greater than or equal to 30. So look, this is the final answer that I want right here. I want X bar minus your margin of error less than mu less than X bar plus your margin of error, where X bar is your sample mean of the sample random sample. Your margin error E is Z critical times your standard deviation over the square root of N. C is your confidence level given to you in the question, right? Z critical, that's what you have to look up in the table, right? And that's going to be the critical value for the confidence level based on the standard normal distribution, right? And you can look that up on the table at the bottom. And that's it. That's a the normal distribution table. Yeah. Yeah. All right. So I know this is a little confusing, right? So let's look at an example together real quick. Oh Lord, I got a typo in this question. My fault, y'all. Let me I know. Let me just fix this right here. I gotta cross this out, right? So it's supposed to be Fanta Maria. All right. So Fanta Maria enjoys jogging. She's been jogging over a period of several years, during which time her physical condition has remained consistently good. Usually, she jogs 2 miles per day, right? With the standard deviation of her time, sigma is equal to 1.80 minutes. Hold on one second. I got you. So sigma is equal to 1.80 minutes. Mm-hmm. All the questions do. So during the past year, right? Oh shoot, here we go again. See, man, I gotta fix this right here. So Fanta Marie. So Let me start it over. During the past year, Phantom Marie has recorded her times to run 2 miles. She has a random sample of 90 of these times. For these 90 times, the mean was X bar equal to 15.60 minutes. Let mu be the mean jogging time for the entire distribution of Julia's why I keep saying see? Oh my gosh, the typos is crazy over here. All right. Let mu be the mean jogging time for the entire distribution of Phantom Marie's 2 mile running times taken over the past year. Find a 0.95 confidence interval for mu. Hold on one second. All right. Yo, the typos, I know. I gotta get better at that. I gotta fix those. All right, so let's look at what we have, right? We know what sigma is. Sigma is equal to 1.80, right? We know what our sample size is. N is equal to 90. We know what our sample mean is. X bar is equal to 15.6. Okay, 60, right? We know what our confidence level is, right? Our confidence level is 0.95, right? So because I know what sigma is, I know that I can use, right, my ZC formula. So let's take a look at what I'm talking about. So we go to our formula sheet, going all the way to the front of the formula sheet, right? So I'm down here, I'm in chapter 8, right? So I know what sigma is. Sigma is known, right? So this is my margin of error formula right here, right? Because I know what sigma is, right? End game, I'm looking for this answer up here. That's going to be the answer to the whole question. All right, let's go back. So my margin of error E is equal to Z critical times my standard deviation over the square root of N. Simple, right?
What is
Now,
E in this case?
that's the question. What is Z in this case? Tell me. I'm looking for Z of 0.95.
Oh, okay.
Mhm.
It's 1.86.
1.96.
Yeah.
All right. Everybody sees how you got that?
Yeah.
Okay. Well, let's look at the table together so that we all on the same page, right? So going back to the formula sheet, we go back to our normal distribution table, right? So here we go. This is our areas for standard normal distribution. If you keep scrolling, as you keep turning your page, right here, we have a little table here called table 3. Confidence intervals for critical values of Z critical, all laid out for you. We have, I forgot what we have, 95% we're looking for, right? So here goes 95. What's the Z critical value? 1.96. That's it. You're done. All right. Let's go back. This is 1.96. Okay. After this, a little bit of calculator. Can I assume we all know how to do this in the calculator, or y'all need to see it done? You see it done? All right. Y'all got to give me like a second. What happened? Yeah. Y'all gotta give me a second though. I got mad ads over here. Every time I open my calculator, I get ads. Which one? The calculator? I'm using the 84. Yeah. But I will explain it to you for the 36X Pro though.
No, that's because my calculator's looking down at the bottom of my line. So I'm saying, when you
So if you're gonna use the 36X Pro, first you start off by pressing the fraction button. That's that button right above the number 7, right? For the rest of us, right? That's gonna be alpha F1, then you're gonna choose the first option. Literally just type in what you see right there, right? So this is 1.8, then times 1.96, then go down, then you do second square root 90, and that's the answer, right? For your calculator now, right? You got to use mad parentheses, mad parentheses. So you want to do open parentheses, you want to do 1.8, 0.8, no, times 1.96, then close parentheses, then second square root. Actually, wait, hold on, no. I'm sorry. Delete that. I'm sorry. Divide and then second square root, then 90. All right, start over. It should look like this second line up here. Open parentheses, 1.8. Mhm. Mhm. And then times 1.96. Close parentheses, divide, and then second square root, 90, and then enter. Or close parentheses and enter, one or two. 0.371, yeah, that's it. All right. Yeah, I know I don't like to round, right? Okay. So let's get back.
Hold
Got you. So we found this number, right? But that's not my final answer. This is what I want my answer to look like. X bar minus E less than mu less than X bar plus E, right? Just plug in the numbers. X bar was 15.6 minus the E, which is the 0.371. I'm just going to round this off to 9, less than mu, less than the 15.6, plus the 0.371. I'm just going to round this off to 9, right? Little subtraction, plus what? Yeah. Or I really don't like rounding. Yeah. Because I don't have the space to write. But if I was really doing this, I'm using this number right here. Mm. Yeah. Which part? This part? Mhm. No, this is a question up here. Has a lot of typos in it. Mhm. That's it.
The sigma.
Mhm.
Standard deviation.
Nice. Okay.
I've been getting them online.
Yeah.
So I don't know find it too hard yet. I got that one on my
Mhm.
laptop though, but it's hard to put them down.
I got you.
On a phone.
I got you. I got you. That's fine too. That's fine too. As long as you understand. Hmm. The confidence interval. This is a confidence interval. Yeah. It's in your formula sheet also, see? I'll show you. This is it. You see where it says chapter 8? Okay. Confidence intervals. This is the answer to every single question for confidence interval. All right. The difference is that you have two different E formulas. Today we're talking about one, tomorrow we're talking about another. And that's it. Mhm. Got you. All right, so I got. Go ahead. Go ahead. What is what? The less than mu, less than? Yeah, that stays there. Yeah, right. This- to English, this is my final answer. This is what I'm looking for. That's it. Hmm? To what? You didn't watch the video?
It's fine, it's fine. Keep eating, keep working on it.
Oh, what is it?
Carrot, eat carrot. Oh,
It's pretty like exercise.
really?
You saw Americanized on Sarah, you Americanized.
I don't know.
He was back home, he was in PR, he was in Africa. Yeah.
I'm not sure. I'm not sure.
You have been here?
No.
And how you know?
Ma vede, sono parte dominicana, io non so, mia mamma, e non importa che come è assim, come se we know, dica how I know that.
Hey, so you guys who got enough funds right now?
I mean, but this a health science question though. Huh? Scroll up. I got you. Yeah.
Wait, one second, but almost have one, just so, one time.
Okay.
A question is, you put this, the finalize and we're gonna carry it, no. Just, if we know how to plug it in, like,
That's it.
this is, because you need the numbers.
Yeah. Need numbers.
No,
X bar 15.6.
18, 22, 80.
So that's all this is. You just plug in the numbers and that's it.
They like that, they don't need it.
Yeah. You think so?
Let's just not put this in the exam.
Nah, this is definitely on the exam. Definitely.
That question compared to them?
No, no.
Not the exact question. I can't even do it. Like you see how many typos I had in this question? Like I OD. Like, look at this. Like, mad typos. Yeah. See mad typos in this joint. Yeah.
So,
I mean, but keep it 100. If you wanted to get the test question, just when you're watching the video, just cut this. Put that joint in like Copilot or ChatGPT. Give me another question just like this, and that's it.
Why? Like that today.
I mean, I'm not looking for all of that. Like, you see the box? That's all I want. You know? Yeah.
Like, if we don't show our work, we just put.
It's your risk. If you give me the right answer, if you give me the right answer, I got you. Right? But if it's wrong, I have nothing else to look at to give you points to, you know?
Okay, you get.
Yeah. Yeah.
You get.
Hmm. Hmm.
They're not being included on the final.
Yo, but the final, the easiest exam. The final is gonna be the easiest exam, bro. Yeah, I promise you. Huh? Yeah, it'll be here. That's why it's easy. Yeah. The department does. Yeah. Yeah. It's gonna be mad easy. Yeah. Hmm. You ain't gonna fail. You got a passing grade going into the final. You all right. Mhm.
Sure, yeah, the fan, big boy, it's a big one.
Yeah, he good. He been on his game since day one, yo. You right. I ain't. He been on his game since day one. Yeah. Yeah. Nah. He got good grades.
It's like happening.
Yeah.
is the cat.
It probably is. You seen that episode of Magic School Bus, right? With the carrot? Mhm. You do? Mhm.
Is the new.
Well, the muse what I don't know. That's what I want to know.
I think question.
How I didn't know that's the prime.
How? You just box it. I'm looking for an interval, and this is the interval. Yeah.
Dale, cat, on both sides.
The less than, yeah. Like the middle part is always there. Just literally just copy what you got on the formula sheet.
Don't.
Just copy it. And just plug in the numbers. That's all it is.
Yeah, but her question is if always will be like no
Minus.
than, no less
Yeah.
than.
Always.
Be like that less.
Always.
Is addition.
Always.
Or you said, plug it in.
Yeah, just copy and paste. That's it. Simple.
What about part C?
Don't be scared. What's up, man? Excuse me.
Michael Jackson was a good movie.
It was? I gotta go see it.
Really good movie.
I gotta go see it.
Like a lot of classics on there.
Yeah.
Good actors. Good actors.
I heard it's his nephew.
Yeah, that is
Yeah.
what's like. Looks just like.
Yeah. Hmm?
Did you show up that testimony?
Tomorrow?
Exam 2.
You got it.
Me and you though.
Nah, not me. You know what it is though? Like I'm not on campus at the time. So that's why
We could do it after college, bro.
I told you about that story, man. It's not me. All right, so look, Interpreting confidence intervals. A few comments are in order about the general meaning of the term confidence interval. Since x bar is a random variable, the endpoints x bar plus or minus e are also random variables. Equation 9 states that we have a chance for the confidence level of obtaining a sample such that the interval, once it is computed, will contain the parameter mu. After the confidence interval is numerically fixed for a specific sample, it either does or does not contain mu. So the probability is 1 or 0 that the interval, when it is fixed, will contain mu. All right. A non-trivial probability statement can be made about variables not consistent. So equation 9, the probability of x bar minus e less than mu less than x bar plus e, which is equal to the confidence level, really states that if we draw many random samples of size n and get lots of confidence intervals, then the proportion of all intervals that will turn out to contain the mean mu is the confidence level, right? For example, right? Good. For example, in figure 8.4, the horizontal lines representing the 90% confidence interval for various samples of the same size of an X distribution, some of these intervals contain mu, others do not. Since the intervals are 0.90, there's a 90% confidence interval, excuse me, about 90% of all such intervals should contain mu. For each sample, the interval goes from x bar minus e to x bar plus e. Let me show you what this is looking like right here. This is going to make a lot of sense right now. This is just talking about why we're doing what we're doing, but exactly what we're doing is the process that you guys just saw. That's all I'm looking for. All right, so once we have a specific confidence interval for mu such that 3 is less than mu, which is less than 5, for example, we can say, all we can say is that we are, excuse me, a percent confident that we have one of the intervals that contains mu. Another appropriate statement is that at the confidence level, right, our interval is one that contains mu. So that's the interpretation of what we're doing. Let me show you this figure. This is going to make a lot of sense when you see it. So check this out. This is for a 90% confidence interval, right? Samples of the same size. So each blue line that you see right here, that's an interval, right? And we're saying, excuse me, we're saying that we believe that the interval that we have contains the population mean mu. This black line going up here, this is mu, right? Now, as you can see, some of these intervals, they definitely contain it, and some do not, right? About 90% of the samples that we take are going to have the population mean mu, but some will not have that population mean mu, right? So this is what a confidence interval is. This is how you estimate what your population parameter will be, right? Excuse me. So what does a confidence interval tell us, right? A confidence interval gives us a range of values for a parameter. A confidence interval for a parameter is based, excuse me, sorry about that. It's based on a corresponding sample statistic from a random sample with specified size n. A confidence interval depends. Hold on one second. This pollen is killing me right now, yo. I'm sorry about that, y'all. Sorry about that. All right. A confidence interval depends on the confidence level C. Common values for your confidence level are 0.90, 0.95, 0.99. Excuse me. If we take all possible samples of size n from a population and compute a confidence interval for each sample, then the confidence level of each such confidence interval will actually contain the population parameter in question. Similarly, 1 minus the confidence level of a confidence interval will not contain the parameter. That's just simple math. So when we use samples to estimate the mean of a population, we generate a small error. However, samples are useful when it is possible to survey an entire population because the use of a sample may yield a savings of time or effort in collecting data. All right. I do have one more example, but time is against us. So let's just do something fun then. All right. They got it? Nice. But she know everything. Yeah. Oh, which one? Oh, I'm sorry. Oh, the gray buff? This thing? You mean the question itself? Oh, so that's part of it, and then there's this part. All right. So in the last couple of minutes, let's answer Danny's question. Mhm.
Same songs, just plug in.
Yeah, same thing. Yeah. So now this is called a confidence interval, all right? So let's look and see where can we find confidence intervals. Let's see. Interval. Oh shoot. Did I click the wrong thing? There we go. So what you're gonna do, you're gonna go over to where it says test, right? And what we just learned is how to do what's called a Z interval. The Z interval, right? In this question, we were given statistics, right?
T36.
This is both of them have it. Both of them have it. I'll go over how to do the other one later, just because time is against us. We only have a minute. So type in what you got. So you got 1.8 for standard deviation. And we know what sigma is. Our sample mean was 15.6. My N was 90. And my confidence interval, which I can't remember, was 95%. Boom, boom, boom. Oh, what happened? Let me let me try that again. Hold on. CL is your confidence level.
That's what we're finding.
No, we're finding the interval itself. My mistake. One enter. And that's it. That's the answer that we found. Do, do, do. See? Mm-hmm. Sample mean. Yeah. Which one? Sigma, the population standard deviation. I think what you're asking for, I see, man. That's called Z critical. Let's see, let's see tomorrow. Z critical, yeah.
You got it. So.
Let me go here.
So we upper son?
Yeah, go ahead.
Gotta make sure I'm level.
So Sarah here, I think this is what you're asking about. Like, what is Z critical? What is the C, the confidence level, all of that. Yeah. All right. Have a good day, y'all. Don't forget to sign the sign-in sheet. Can I take this down?
How much on this?
I'll see you. I'll see you. See you. I can take this down. It's cool. Yeah.
No